Christian is helping with the sharing part. So, because we were discussing that we would like to share with you so many things about OpenQuake that maybe we are overwhelming about so much information. But before moving to the probabilistic risk, I will just wrap up OpenQuake. So, which calculators we have, what we need, and please stop me if I'm going too fast. If you have any question, we can all go slowly through those steps. Thank you.
Do you want to stay over there, just for the camera better?
Okay. Yeah, sure. So the first question is, which calculators do we have? OpenQuake, we know that is a software for hazard and for risk. But then we would like to know what type of outputs I can get. So here is a summary in which we say, for hazard, if I'm interested to assess hazard, so I can do scenario calculations, which means estimation of ground motion fields. I can do the classical PSHA, which is what Michael presented today, that you will have for the entire Canada open. Or we will have, or we can also have event-based PSHA calculator. So far we haven't touched event-based. That will be the second session and last one about like the exercises. Then if I want to compute risk, which calculators do I have in OpenQuake? So if you are talking about deterministic, so I can have scenario risk calculator or scenario damage calculator. So yesterday we ran both. No, we ran damage, but in the spreadsheet that was our task, we had also the option to run a risk. Then if we are talking about probabilistic risk outputs or calculators, we have the classical PSHA-based risk calculator, and we have the benefits cost ratio calculator. Then I will go a little bit slower through all of them, what is needed, what are the results, so we can maybe have an idea what I want to compute, which calculator I should use. And finally, we have the probabilistic event-based risk calculator, which is the one we are going to run. Because of time, we didn't manage to do all the cases or the examples, but eventually when you go back, you have all the data you need to go through all of them. Also, we are very happy to have volunteers for do demos, training, videos about OpenQuake. We haven't had the time, but if anyone wants to record, reach out, tell us, could you publish in your social media, in our YouTube channel? You are very welcome. So let's start wrapping up. So we have hazard and risk. For hazard, we have deterministic or probabilistic, and for risk, we have a bunch of options. But what we need in between, we saw it is the exposure model and the vulnerability model. And the link between both of them are where are the buildings located and which building class I'm talking about. So exposure will tell me the location, vulnerability will tell me how they will behave under a given ground shaking. And we have two options. It's good that at the end you will understand that at least in the OpenQuake terms, if we are talking about fragility, the results will be damage, because fragility represents the probability of getting a damage state for a given intensity measure. Instead, vulnerability will assess losses, which means a loss ratio for a given intensity. So for hazard, when we divide, which are the input data required by OpenQuake? Did anyone ask why, when you were running the hazard, we were selecting a job? No. What does it mean, job? Some of you have already used OpenQuake in the command line. So in the OpenQuake jargon, we call job is the configuration file. It is the file that I tell as a user to OpenQuake what to do. So far, we have doing like hidden is the file that Anirudh went through when you have the options and tell the instructions to OpenQuake. And the IPT is just simply like making our lives easier. So you have all the options there and you click, but behind is building these configuration files. So both calculations will start with a configuration file. If I have a classical calculator, so I will need the source model logic tree. Michael already talked in detail what the source model can have. Then I will need the sources itself. So that's the source model. And then we will need the GMP logic tree file. That is the one that tells me which ground motion prediction equation should I use based on the tectonic regime. And these 4 files are the same for probabilistic risk, risk based on PSHA, and for stochastic catalog. So the input files are the same. So the ones that we are going to use in the next exercise will be the same that you use today in the PSHA. Then if I have the deterministic, is the scenarios that we run. Basically, we generated one file, which was the rupture model. And then we gave the instructions of, do I want to run the median, or I want to include uncertainty, which GMP do I want to use? So that's the code configuration file. Is it clear up to here? Then we will build on top of that, because now we are going to risk. So in risk, again, this is the summary of the calculators we have and which are the input files. Very simple. Exposure, vulnerability. If I want to estimate damage, then I go to fragility and the configuration file. So yesterday, what we did in the steps that we have been followed, first we run the median. Let me here, I can click. So first we run the median ground motion field. We add the exposure model that in this case is representing location, cost, population. We combine them with the fragility functions for each damage state. So we were evaluating collapse, slide damage, etc. Then we use OpenQuake. And which were our outputs? Our outputs were either statistics regarding damage distribution, when we were exploring how many wooden buildings in industrial facilities were collapsed. So these are the damage statistics. And we can also get damage maps. So we have in the damage map the distribution of damage for a given damage state. This is if I use the median value, but then we can also do multiple simulations of the ground motion field to include the aleatory variability, and we get the same statistics. As risk modelers, we really encourage to use multiple realizations, because usually when you use the median value, you underestimate your losses. Yesterday, we managed to do this because you were very keen to continue doing OpenQuake exercises. You went home and you ran the losses, right? So then what we did for losses, if you read the homework, was instead of using the fragility file that we had, it was replacing that for vulnerability. And in the IPT, you will remember that you have the option to select damage or risk. So if I go for losses or risk, in losses, I will input the vulnerability functions, and instead, I will get a distribution of loss, which means how much was my economic loss, and how many people were affected under this event. And again, we can also get mean loss maps that in this case will represent the spatial distribution of the economic losses. You can run with one or with multiple realizations. The same concept goes. You should really use multiple realizations if you want to estimate your losses. Then this morning, Michael and Anirudh presented how to perform PSHA, and the results of the PSHA calculator are basically hazard curves. Could be hazard curves, uniform hazard spectra, could be disaggregation, and now we know which are the input files. What are the other options that we won't have time to go through the classical PSHA-based risk calculator? If you want to do it, you have now the input files are the same that we will use for event-based. So feel free if later you want to explore this. But in this case, we combine the exposure model, the vulnerability function, and as a result, we will get the loss curves, which will represent, it's very similar. It's like the comparison to the hazard curves will represent the economic loss for a given return period of a probability of exceedance, and the loss maps. So because we won't have time to go in detail on this topic, this is just an example, different assets in this case are representing different locations, spatial locations. And I have on the left the loss ratio for a given probability of exceedance. And then I have also on the right the losses. So I can get loss ratios or losses. And to produce the loss map is the same procedure as for a hazard map. If I want to know the 10%, and let's say that this is the 50 years, I go for each asset and I get which are the losses for each of the assets. And finally, I will have a loss map. And this loss map is the probability of exceedance. This is 10% in 50 years. And Murray, please correct me, is more or less what you are doing we are going to have for Canada for some policy when we are saying we want that the buildings do not collapse in a given time span. This is the example for the 10% in 50 years, and then is the 1% in 50 years. So these results, we won't visualize them today, but are available for you to explore in case you want to extend your calculations to this topic. Then we have the benefit cost ratio calculator. Basically, I delete the equation. But you can have, in this case, two vulnerability functions, which are original one and retrofitted, and you will get on a given time span what is the economic benefit of retrofitting that building, if it's actually worth it or not. And you can also have maps or curves for this calculator. So now let's go into the topic. This is the calculator that we are going to run today. And at the bottom side, you will see that the results are quite different. So be careful, because for risk estimates, depending on what we want to get, we have to use different calculators. So on the top, we have the input files. And again, it's the PSHA model, it's the exposure model, and it's the vulnerability model. Then, in contrast, I will get loss curves, which represent what is the expected loss for a given return period. Before, it was asset-based. This is very important. In the previous calculator, in the classical calculator, I will get those curves for a given location. In this case, I will get it for the entire portfolio of buildings. Then we can get average annual losses, and we can get also loss maps. In this case, it's China, showing the average annual loss. Why are we going to this is because is the usual calculator that we use for financial protection, or if we want to understand what is the premium that I need to pay, or if I want to say where to invest in a given city, I need to look at it in a portfolio base and not at asset level. And the difference is, why we have to use that? That is the question. Why I can use the classical PSHA? And one of the first sentences that Michael said in the morning is, when I'm assessing a PSHA, I want to consider all the possible locations, all the possible events, all the possible magnitudes in a given site. And what the hazard curve gives me is like the envelope of that sum. But when I go and I move to risk, we know that the earthquake that occurred in Montreal won't affect Victoria, right? So if I do that calculation, I will overestimate the losses, because of course the earthquake in Victoria, we won't feel it here. So what we do, this is an example in Taiwan, is that we, instead of going through the convolution of the hazard curve with the vulnerability, which is the procedure that the classical calculator does, in this case, we are generating stochastic catalogs. So for a given time span, this is 200 years, for example, I will generate different events. Based on what? Based on the source model that we have in the PSHA. So I have a recurrence rate, I have 7 given characteristics, so I want to model many options. And for each of those earthquakes, here we can see points, but also we have it's a rupture, so it has a given geometry. As the magnitude is increasing, we are expecting larger area to be affected. And now, for each of these ruptures, So let's select one, this one. For this rupture, what I'm going to do is I will generate the ground motion field. Now we know this is a scenario, right? I generate the ground motion field and I generate the economic loss. Now we know how to do that. But what about if I want to do it for 1 million events? So what we'll do is generate it for many events. And for each event, I will store what is the total loss. So I will say for the event with a magnitude 7 located in the southwest of Taiwan, the losses are 3 billion. So I will start building this curve. And so this earthquake that we selected is generating 3 billion. So it's located in that point in the curve. Then what about if I do that for every event? They will have a point in this curve. If I do a bigger magnitude, I will expect, and if it's close to the place of the assets, I will expect larger losses. And in that way, we store all the losses, the total loss of the portfolio coming from each event. And this is the loss exceedance curve. Any question? Was it clear?
But you have a distribution or different values depending on the zone or the municipality that you have.
Yes.
Is there a way of putting like that into a equation or a curve that gives you like a more detailed value instead of just taking the whole? Let me rephrase that.
Yeah, I cannot repeat the question to the online participants.
Let me rephrase that. Is it okay to take the total loss, or can you take, for example, the maximum loss or the average loss in the distribution to get from that?
Well, it depends. You can do. The question is, once I generate a given event, can I get other values instead of the total loss? Can I get the maximum or any other metric? The answer is you can, and you cannot. So you can do it if you go into detail in the calculator and try to get information. But right now, the event base is only looking at the total portfolio loss. So you can get also losses per asset. But you want to say?
Yeah, so we look at, depending on the questions that are being asked, we can look at either the aggregate loss for a given region of interest. For many of the folks that we're working with, are actually interested in the asset level loss. So we run the models at the asset level. So for any given location, we know numbers of buildings that are there. So we essentially run the model for that class of buildings at that location. And we can, because of the stochastic approach designed for portfolios, we can aggregate up from that if we want. But we start at that very granular level at the asset level, and we do that for all assets across Canada. So we have that base level of assessment. Does that help?
Yeah, also we can later explore like some of the others. Okay. Any other question?
So to each rupture of earthquake is assigned a probability because I expect a larger earthquake to be less probable than a smaller one. So also to the loss, I assign for each scenario is assigned probability.
So the question is, does if a rupture has a given probability assigned? And the answer is, when we generate such ruptures, we are considering the occurrence rate of each source. And then you have a given time span, and you can check which is the occurrence rate of each rupture to generate this, because it's actually what we are doing to compute the return period. And also, it's possible then in the outputs, we won't go into that detail. If you want, we can discuss. But in the outputs, you can go back and say which event, which rupture generated, let's say, the loss that I want at the 200 years. So I can go back and check which set of ruptures are close to that point and identify the ruptures that are causing those losses.
So you mean that for each point on the curve, it only come from the damage from the time function model?
Yes, but these curves can have million points. Okay, so it's not, we see it here very smooth, but it depends also how many years you are modeling. You will get more or less. And we will now see the values from where we can get this curve. Yeah. Yes, but also you have to, wait, sorry, do you want to say something?
Yeah, there's a distribution of losses around each one of those points. There's a set of events for each one of those points, and then that line is presumably the mean.
Indeed, this here is the mean because we have multiple realizations, and then we have to take based on the weighted mean actually what we can present, and we will see in the Handson exercise that we can get also the curves for each realization or each path, which in this case is combining all the hazard. Like if we have different sources, different GMPs, we can see which one is generating or which one is contributing to the total mean. Anita, do you wanted to say something else? Okay. So
you can generate multiple synthetic catalog for a given time window. So I guess you will not generate only one synthetic catalog for 1 year. Just generate like thousands and then.
Well, this is a time-independent model, what we are right now handling on. So it's more or less the same if you generate one stochastic catalog of 10,000 years, or you generate 100 in 10 years.
No, I mean for one time window, you generate only one stochastic catalog, for example, 100 years.
Ah, okay. No, it's based on the occurrence rate of the model. So you are starting 1 year. So in 1 year, there could be multiple events that occur. Is it that the answer or no?
So there are a couple of ways you can do it. You have to look at, this is an example of 400 year data, just plot the map. But if you have a time-independent model, then you can create a catalog of like 1 year catalog and do about 100,000 of these 1 year synthetic catalogs. Or you can do one large catalog spanning 100,000 years, and then we do similar results.
Thing is, if you create a synthetic catalog, given some probabilities and some faults in 200 years, you do it once, and if you do it again, the two catalogs will be different. So, is that?
Yeah, there is a way in which can specify how many synthetic
It's like
catalogs.
catalog approach. So
You can generate 500 of these 200 year catalogs and then run the calculator for all of them, and then you get the results across 500 of these catalogs.
And there is also like let's say we have also options. We won't explore it today, but when we open the job file, there are some parameters that allow me to reproduce again the same value. So let's say I run a catalog for 100 years, and now I want to get something different. So it's called the random seeds. There are different types of random seeds. You will have to read the manual, but you can specify those random seeds and generate for the same year different catalogs.
by one catalog, you randomly select some function models to form a catalog. Or
Sorry, can you
repeat? I didn't quite understand what you mean by one catalog or 5 catalogs. How do you?
So when you have a PSHA model, you have internally some occurrence rate of the events. So when we say a catalog, we think in a investigation time. Let's say I would like to see how is the seismicity in the next 500 years. And based on those occurrence rate in 500 years, I will do a Monte Carlo sampling, and I will generate possible events based on the distribution that we believe the PSHA model is giving in that side. So, any other question? Or we move to exercise? Oh no, actually, shall we break or? So what do you prefer? We do the exercise now? Or I not yet? Okay. So no option. So now let's go to actually generate these metrics. So I'm coming back. So everyone now is hands-on. So you have to go, you have your QGIS project open. And here I have it very clean. I have also my calculations. So we say we can generate the same type of results using the data that we already have. So what we are going to do is use the PSHA input files that we just use for visualizing maps, and we will use it to generate these risk statistics. So we go to the input preparation toolkit. Sorry. And now, so far we have, I'm using the mouse of the other computer. So far we have only explored one of the tabs. So we have come to the configuration file, and we have only explored the earthquake scenarios. We have other tabs, the classical risk, the classical probabilistic calculation says coming soon. It has been coming soon since the last 2 years, and I believe it will be like that for a while. But again, we receive volunteers as well. But then we will go to the stochastic event base. And I just say that because some people were confused that in this calculator, I can generate PSHA. We can generate a hazard map because we are doing exactly the same. But is it my hazard map going to be similar to the one generated by PSHA? If I do enough, if I investigate the catalog for a long time, it should approach to the classical one. So in the classical events approach, again, we can have hazard and risk. If I'm only interested in generating the stochastic catalog, then I can just run hazard. But today we will run hazard and risk. Now in the, we can say event-based calculation. Example, I will put again Charlevoix, so you can use the same files as well. And Charlevoix means the region, not we are not doing an earthquake scenario, but we are going to take the exposure model that we use for the exam, for the exercise yesterday, and same the vulnerability functions. As you can imagine, I guess, this is the most computational expensive calculation that you can do. You can go crazy. Oh, I would like to explore the next million years. And it depends. If you are in the Pacific Islands, you could generate 30,000 events in 1 year because there are many. And also we can specify what is the minimum magnitude, the maximum is inside the files. But the idea is be careful when you go back and you want to do event-based risk for Canada, because we have multiple challenges. It's a huge country with a spread population. I mean, spread, I'm saying, if you want to account for the ones that live in the north, then you have a huge area. The exposure model is very detailed, and we have many building classes, and we have multiple source models. So as much you want to increase, as much your calculation will, the time of the calculation will go. So for that reason, we will try to run this calculation considering a hazard grid in few locations. So this is to make it run in our computers. When you go back, you might want to start gradually, really, that's the recommendation, gradually increase the precision of your calculation. Otherwise, your ITs or your computer will regret that you are breaking the servers, like we have done a couple of times. So let's go and select hazard sites, and we will say region grid. The region grid, we can put 10 kilometers. It will be up to some computers have been a bit slow, so be careful. Do not go, I want to run it every kilometer. No. Here the advice is 10 kilometers. And then we have the option to say let me increase this maybe. Better, right? So we have the option to say infer region coordinates from exposure model. So I don't have to go and look for the latitude, longitude. It will get all the polygon based on the exposure model, and will only use the sites that are close to the exposure model. Okay, so we will put this option, and that is the locations at which I will account for my hazard. Then we have the option for site conditions. Again, we can use a uniform value, we can use a site model. How to select it will be dependent on the available data. Maybe if I have data at the asset location or in a region, it's another topic, another world, so you could go there and explore that. We will use the value that Michael recommended this morning. Let's say we will use 450. For a real calculation, what we generally do is select the BS30 based on the location of the assets. So we optimize also in that way that we don't have a very big file. Then we will select the source model file. And for this, we will go to the folder in which we have the PSHA model. So we will go to upload, we go to the exercises, and we click on PSHA. And on the PSHA, we are selecting the source model logic tree, right? And this is the one that by convention we call SSMLT. So the ones that are lost, raise your hand that still we have people around to give you a hand. From there, we will select the source model file. The source model logic tree. Then we will upload the source model file. Because we are simplifying, we only have one. But if we want to run this for the entire Canada, we will have, I don't know how many files you have for source model, so it could be a lot. So we upload the file, make sure that you select it here. Then we will select the GMP logic tree file. And we will upload it. So in the logic tree file, in this case, we are giving weights to each GMP. Yesterday, we were not giving weights. We were just saying we want the central, the high and low ground motion prediction equation. But in this case, I can give a weight and say in which ones, based on the expert decisions, which are the weights of these GMPs. Then we have some parameters that can be modified based on the needs. We will leave the default, but this is basically saying being with of the magnitude frequency distribution. So now we are sampling all the possible events in a Monte Carlo way. So if I want to split for, let's say, 4.1, 4.2, 4.3, all the possible magnitudes, so here is when I say my bins. Which are my bins? We are putting 0.5. Same for the rapture mesh spacing, the area source discretization is how much I want to discretize to create those random events, which are similar parameters that you give in a PSHA model. So if you are running your model in Western Canada, you might need to include the complex fault mesh spacing because we say that the subduction areas are modeled as a complex fault. In this case, we are in the east. We have only a simplified source model. We don't have to use it. If I put here this parameter, there is no problem. OpenQuake will ignore it because you don't have complex faults. If you have and you don't put it, then you will get an error message saying, you don't have a complex fault rupture mesh spacing. So far everyone here. Am I going too slow? Okay. The ground motion model correlation is a parameter that now you are used to. We say yesterday we can include it or not. It's extremely computationally expensive, so we won't use it until it has been optimized in the engine. We have maximum size to source distance. Again, if we are in the stable class, we can increase it more or less. We will leave the defaults. The level altercation, Michael already talked this morning. This is the way we measure the aleatory uncertainty. How many sigmas do we want to include or not? We will leave it in 3. You can explore what is the effect if I put it 2, if I put it 5, and how the risk metrics will change based on this decision. And here we have the parameters that we were asking before. How many years do I can model if I want to generate 1 stochastic catalog, if I want to generate 5 stochastic catalogs, and what is the time span? So in our case, we will put a hazard investigation time of 1 year. And we will use, 1,000 stochastic event sets. It means we will generate in a time span of 1 year, 10,000 times the catalog, and we will have that time window. I could change it and do the opposite. An investigation time of 1,000 years and 1 stochastic catalog. And again, the result will be pretty much similar. For the number of logic tree samples, in PSHA models, we can have super complex models that have many possible realizations. How many had the US user 3? So 4,000 branches with multiple GMP. So you start multiplying, and there is no way that we can do a full sampling of all those branches, unless you have a lot of time, computer resources, patient to check how to run. So when you put 0, you are saying, I want to sample all the possible branches. Or otherwise, you can do a sample of 50, 100, and they will sample those branches based on the weights you have in your logic tree. We will use 0, we just have 3 realizations. Again, we have the lower, the central, and the upper GMPs. For the exposure model, you most likely already uploaded, because we say we are going to use the same exposure model as the example for Charlotte. That it's a scenario, but we can use the same exposure model. So I just click here in the arrow, and you can already select the files that we have uploaded before. If you want to clean this at the bottom, I'm saying this because usually I miss it and I have to ask the ITs, how can I clean this? And here at the bottom is an orange button saying clean all. So if you want to delete all your data, you just clean all, and you will have all the pre-computed fields clean. So we put the example for PSHA, sorry, let me turn off. Then yesterday we used fragility functions that again represent damage. Today we are going to use vulnerability that will compute losses. So we will use structural losses. We can select structural, non-structural, contents, business interruption, occupants, and in our case we will only select structural occupants. In the data sets you have the vulnerability functions for Canada, for non-structural and contents, but we won't use it just for simplifying things. If you want, go ahead and be careful with your computer. Let's start simple and then start scaling. So we just have to go to, now we have to go to the scenario folder because it's there where we have the vulnerability functions. So let's move to the exercises. Let me see. Also in the event base, we have the structural and the occupants. Okay? So we will upload the structural function for the vulnerability and then for occupants. And finally, we have the parameters for the risk calculation. So now they are telling me, okay, now you input all the, you specify all the input files. Now tell me what you want to compute. So by default, the event-based calculator will give you the average losses in the time span that you specify here. If you want the average annual losses, so you have to put the risk investigation time equal to 1. So it will analyze the losses. Then we can tell at which return periods we want to estimate the loss curves or the loss exceedance curves. By default, it's empty. You can see numbers, but if you check are empty, are just a placeholder. If you leave it empty, OpenQuake will do more or less these numbers. It's a default. If you want to specify a given return period, you can put only 1 and you won't get a curve, you will get a point. OpenQuake will estimate the default based on your investigation time. Does it mean that I can trust the losses for 1,000 years if I'm modeling a time span of 1,000? Absolutely no. I have only one event that will exceed that value. So to get the actual meaningful result for a given return period, I have to go way beyond my investigation time. We will leave it for now empty. And then some other outputs will be if we want to generate hazard curves or include loss maps. We won't use that today, but later we can explore some. And then we have included also some quantiles, so we will see how the loss exceedance curve will change if we consider some quantiles. So we'll see the range of variability. Then you are now experts on how to run OpenQuake, download the file, go to the user interface, upload your zip, and we will wait until the calculation finishes. So I will download, then I will move to my QGIS, and I will run the event-based hazard and risk that appears in my download folder. So I open, here it is running. I have a bit messy my terminal because as you can see, before doing the workshop, we have to run a couple of calculations and have some error messages. I hope you get some error messages due to files. So if you start exploring and doing calculations by yourself, you will get a lot of error messages. It has been a long path telling our developers, you know, this error message is not clear, we have to improve it, what do I have to do to check my model? So if you find those strange error messages that you don't have a clue of what is happening, we have the forum, you can write there, and there is a bunch of people that can help you. If it's actually a problem of the engine itself, we will go and modify the error message so future users will be able to handle that mistake in a better way next time. So if we check the console, again, it's telling you how many sites you are using. So we are using an exposure model with 120,000 assets in 1,400 locations. How many events are generated are in these files, so you can start checking how many ruptures. So the composite source model has 1,800,000 ruptures, so you can see that there are big numbers. When we will see the results, OpenQuake is filtering some ruptures where we don't have assets, or also is discarding the events that cannot produce a given threshold of losses. And are parameters that it can personalize in the configuration file. Right now we don't have them, but for advanced users, let's say I want to have a threshold for the magnitude, I want to have a threshold for the minimum intensity, minimum damage. All of them, you can personalize them because we are start filtering events that do not produce a significant risk. Yes, we had a question. Okay, So mine was quite fast, was 100 minutes. As an example, when we started using OpenQuake at large scale, we were testing a model, I think for Colombia, it was taking 2 days to run. In our servers, now it takes half an hour maybe. So we are putting a lot of effort to optimize our models, but it's only when we have such big models that we can actually improve how we are handling such calculations. Okay. Now we will go to visualize the results. So how many of you have already finished the calculation? No. Yes. No, it's running. Okay, so let's give 2 minutes more so we have more people that have finished. Yes, we should break for lunch and maybe later come back and see the results. Does it sound good? Oh, for everyone? Okay.
One for you, maybe 30. So because the effective period for considering 1,000 detectable events, and each of the duration of 1 year. And what would be? How can you decide whether to consider 1,000 events duration 1 year or 100 events duration 10 years? Because we could end up with the same effective period, which is 1,000.
It's not. I mean, you can consider either, and the result will be more or less the same.
For some time-dependent models, you might be referring to the question is how do you decide whether to use 100, let's say 100 catalogs of 1 year each, or one catalog spanning a longer time span. For time-independent models, there you can switch between the two approaches, and statistically you should get similar results as long as you're sampling enough events to get meaningful results from the squares. If you have time-dependent models where the generation of the next event depends on the previous events, the time between events is not going backwards in the process, then you might have some constraints on the length of the stochastic catalog. So you might do 1 year, you might be constrained to use the 1 year catalog. Then you have to generate many of these, 100,000 of these 1 year catalogs. So in that case, you're forced to choose one of these options.
So we can go for lunch.
Somebody's asking on the online.
Okay, so let's break for lunch and we can ask, or is that a question for
The question is that some people are getting an error if they do not select the source model file.
Okay, let me go.
Yes.
Yes. So make sure that here, when you upload the file, you have to select it. So if you don't select it, you will get that error when trying to download the file. So just come here and select we are using, this is very difficult to pronounce. So just look at the screen and it's this file. So make sure that you select and then you will be able to download the zip.
Is that you may have uploaded many source model files and you would like to use only a few of them. So that's when you have to select the ones that you actually want to use in the calculation. In this case, we have only one, so it might seem a bit silly to select the one time.
Okay?
So we'll be back by 1:30. Take a break for lunch, and then we can come back and see the results.
Keep sharing.
Oh, that's yours. Oh my goodness. Sorry,
I was doing the same.
Okay, let me get this up here.
So I have to repeat the question
Yes.
for the online? Okay. So again, now maybe everyone is paying attention, and we say, okay, which intensity measure type are we using for our risk estimates? I'm running a scenario. Yesterday we did PGA, spectral acceleration, and one. But what are we using now? Any guess? Okay. So the answer is, we are using all the intensity measure types that are indicated in the vulnerability file. What happened? When I derive functions, if I'm looking at that 20-story building that might have long periods, I probably will derive the function using 2 seconds. But if I'm working with 1-story rigid structures, I might be looking at 1 second. PGA, sorry. So all those data, OpenQuake is getting your vulnerability file and is using all the intensity measure types that you are checking. If you go to the top of the IPT, if you unclick the risk button, you will see that then in the hazard modeling part, now you will see the section specified intensity measure type. So because now I don't have that reference information, so now here I will tell which intensities should I use to generate the ground motion fields for my given scenario. Okay, that was a question that I thought it was good for sharing with everyone. So now let's go and visualize the results. This will be the last working with us, all together in the same exercise. It will be quick, so let's go to the QGIS project. Did everyone manage to run the calculation? Yes? Please, any help? We have here 3 people waiting to help. So there are several outputs. We invite you to explore in more detail based on your interest. Some people want to see the events, all the list, but so we will go with the basic ones. So first, we would like to see the ruptures, right? We are generating a stochastic process, so where are the ruptures? So we have a file that is called ruptures, earthquake ruptures. And we have the option to load layers or to download the CSV file. Let's click on load layer. And you have the option to select the visualization by tectonic regime or by magnitude. Then you can select either of those. In theory, we are only working with a stable continental, so it won't make the difference. We can say magnitude. But if you already click OK, you will be very disappointed because you say, I don't see anything. The reason is that we just discovered yesterday that point sources are not being plotted. Do you remember the image we showed with the ruptures around? To do that, you need to have fault planes. But Michael mentioned in this area, and please, Michael, correct me if I'm wrong, we are modeling the events as point sources. So when you see this file, we won't see a physical output. What we will see, if you go and right-click and say Open Attribute Table, we will see the list of ruptures that were generated. So we did a stochastic catalog considering 1,000 years. And here on the top, we can see total. Total is 215 rows, which means that we generated 215 ruptures. But ruptures can have multiple occurrence. So if you check here in the column multiplicity, you might check which are the ruptures that occur more frequent. So there are some ruptures that occur 3 times, 2 times, and so on. If you compare this with other regions, this is a very low seismicity. Of course, we are in the stable part. If you go to some other regions, you will find in 1 year so many events, ruptures repeated 40 times in a short time span. And then we have other information like latitude, longitude, centroid. So if you upload this file as a CSV, download it and upload it again, the ones that are already used to QGIS, you will see the points where are located. Do you want to see it, or should I continue? Do you want to visualize it? Okay. So to visualize it, we will go again to the output files, and we will download the file in CSV. So I will put it by default in my downloads folder. It's this file, event ruptures, download in CSV. Once you download it, you can click, go back to the QGIS layout, and in the left top corner, probably for some of you, you will find this icon is like a comma, which means to upload comma separated file. If you have any difficulty finding the files, raise your hand. That's Sujan, and Anirudh can go around. So let's click here, and then this is basically QGIS. You can select the delimited text option. You click on upload, go to the downloads folder, and the output is downloaded. The name has related is based on the number of calculations that you have run, so the calculation ID. And at the end, mine is called output 212. Yours should be called output some numbers different than mine, depends on how many runs have you done. And then we say open. Then at the bottom, you will see we have to skip the first line. These are many steps. So please, I will shortly repeat. You come to the left corner, there is a comma, delimited text, and you will upload, select here, and upload your CSV file, the one that you just downloaded. You will click in upload one, skip one line, the first line, and then you will see that by default, the software is telling you, I will use the X field as the centroid longitude of the rupture, and the Y field will be the latitude. You click on add, and then, let me close. You will see the points that were generated. Let me turn off. I will put it here, and I can turn all this. So basically, all these points are the ruptures that were generated in that event. So we are considering an area that is more or less here, and this is 1,000. If I generate another catalog, changing, do you remember that rupture, the seed file for the randomness of the event, then I will get other random points. If I investigate, instead of 1,000, 10,000, then I will get many more, more points in the picture. So for the ones that are uploading, you go to the comma, select here the file that you want to upload. Sorry? And here one. Then once you have that layer, you can change the colors, plot it by magnitude maybe. We would like to know where the maximum magnitude are located or not. Later we can do, if we have time, we will do that. So anyone delay, or should I continue? If you don't say anything, I will continue. I will assume that you are okay. Yes. Okay, 5 minutes. So after you bring this file, you have to come and say number of header lines to discard. You have to put 1. And you will check if it's correct, because the software by default will select the X and Y file as the long and lat of the CSV. And then you add the file here at the bottom. You click on add, and once you add it, you close, and you will see these points. So, Here it says 5 minutes. I think 5 minutes is a lot. Okay, so after I see the raptures, the question is, I generate raptures. The raptures can be in multiple, can be repeated multiple times, and we call it events. Is that combination? A rapture that occurs one has an event ID. Then we can have another event, and another event. So we can see those events when we load the table for events. But before we check is, again, I'm repeating, we are discarding some events that are below a given magnitude threshold, which might be of interest when I'm doing a PSHA, but might not reflect any effect when I'm doing a risk assessment. Okay, so just to optimize the calculation, for instance, I might say, even though my PSHA model is considering events, I don't know, what is the minimum magnitude in the model? 4.8. So I could say, in my case, I would like to assume 5.5 events that have that magnitude, or maybe I can go and say I want to discard events in which the maximum PGA is 0.05. So I could discard those events. So we won't have the entire set of events. We will have the list of the events that generate losses. Okay? So let's click now in the events output, and we click on load table. I will repeat that. We click in the events and load table. Okay, next. So do you remember that we have 200 something raptures? But here we can see that the total number of events were 672. What am I looking at? Here on the top, you have a summary of how many rows. Each row represents one event. And each event has an associated ID, an associated raptor, so I can go back and check in the raptures which rapture is generating this event. And later, when we will upload is the losses, I will be able to know this event with this rapture, this realization. So we have 0, 1, and 2 for the central, low, and upper. And we will be able to combine all the ingredients. So this is just a basic table for you to see that we have around 700 events in our 1,000-year catalog. So the next output that we would like to see, we want to see curves, we want to see maps, we want to see like something more exciting. So let's start by the aggregate. And aggregate, you see here, average asset losses statistics. It works pretty much the same as the scenario. If you load the layer, you will see the geographical distribution. We can create maps. If I click on aggregate, I will get summaries. So before we click, let's ask ourselves, what do I want to see from the average annual losses? So maybe I would like to see the total average annual loss of that portfolio. What does it mean? For instance, if I'm the governor or the public office in charge of risk management, I might be interested in checking how much should I be prepared to spend in my premium, for example, for an insurance company, regarding losses, if I want to insure all the assets, all the buildings. So here we can check that by clicking on aggregate. And the first thing we have to check is which type of aggregate do we want to see. Remember that we use 2 vulnerability functions, one for the structural and one for occupants. So we will get the outputs for those options, structural or occupants. If I check a structural, my outputs mean economic loss. So what is my average annual economic loss? If I check in occupants, I will see is what is my average annual fatalities. Because in my occupants vulnerability function, I'm modeling what are the fatalities. Okay? We have a summary in which you show mean, quantiles that we specify in the job file, and you will see here how different, here we will see how they look like. These can also be explored by realization. The results here have the weighted mean, and remember that in this case, the logic tree can have different weights. It's not like the scenario. In this case, we are specifying a given weight. And I hope you have been more familiar now with this interface. You know that you have different tags. So now I would like to see those average annual losses from which, let's say, building class are coming from. So we can go this tag. I don't know if you remember, for sure you remember by heart the meaning of all the tags in the exposure. So you will go and check BLDG GEM, means building general classification. So let's click in this building general classification. Should I repeat? So to this window, we click here in aggregate. Aggregate, open the window, we select which type of losses we want to visualize. If we want occupants or structural, we want structural. Did you check yesterday from where in the scenario, where the loss is coming from? From which building class? Did you check? What was the answer? So, where? Okay, here we are saying steel. Any other guess? Unreinforced masonry. So when we check these losses, we have to go and before understand our exposure. So here is Murray, and we can say, what are the characteristics of these buildings? In the region, we have mainly wooden buildings, right? For the residential exposure, we have some concrete, we have some steel, but that's why you have that summary Excel file with the exposure characteristics. So you can go back and check, because now here is not only related with if the buildings cost, the steel buildings are more expensive, or if the unreinforced masonry are weaker. It's a full combination between where are the buildings, how many we have, where are they located, and how is the seismicity. So we are mixing up a lot of concepts that we have to question all the time the models to understand if our results are meaningful. So by doing that, this tool is trying to summarize, and we can start exploring. Okay, let's see which are the buildings that are contributing the most to the average annual losses. So we will check here the building, BLDG GEM, which means it's a general category of buildings. We might have wood, 1 story, 2 stories, 3 stories, designed in before the 60s, with modern core, modern code. But here we are collapsing all the wood in one category. So we select that, and then you will have another drop-down list. We didn't have time to go through this yesterday, but it's the same interface when you will run the scenario losses. It's exactly the same. So now the star, when in OpenQuake you see the star, means give me the statistics considering all the tags. So all the values. So it will be, in this case, give me a statistics considering concrete, manufactured, precast, reinforced masonry. So let's go and click on the star, and we will see now how this table will transform. I don't know if I clicked it correctly. Nice. Now you can see, if you export this, I guess, to Excel, we can export it here to Excel. You can say save as. But now we can identify which are the building classes that are contributing the most. So if I'm the planner, where should I invest my money? because we cannot have probably resources to retrofit all the houses. So we can go and start saying, okay, if in this region I have maybe wood, if I do some decision to reduce that vulnerability, to increase the resistance of the buildings, the capacity, then I will see here visualized in a fast way how we can check. So we have a question. Those are those losses in Canadian dollars? The answer is yes, right? The exposure model is provided in Canadian dollars, and thank you because we didn't mention that. So for the models that you will be available to download from the GEM website, we have all in US dollars. Okay? So it's so much information that is coming out from here, and that was we have the spread, like the task, the homework, because then we can keep questioning our model. From those buildings, which ones were used for industrial purposes? Or which of those are located in Toronto? Or which of those are located in Quebec? So if we start selecting more tags, we will be able to create filters. So we can start building on top and create more filters. So if you do here, for example, occupancy, then you will have a drop-down list. Which one do you want to see? Governmental buildings, education, residential. So if anyone is not up to this point, raise your hand, we can go around. And the others, the invitation is explore how it changes with fatalities. Get understanding of what we are seeing, because one big challenge is to question and understand if our results are meaningful. And Murray and the natural resources is very open to say, if you find something in those models, welcome, report it. Tell us that is the only way that we can actually modify, because it's so much data that can be overwhelming the amount of work that takes to go and check. And moreover, that you might be experts in different regions. So you can have a very rich knowledge in information for Quebec, the other one for Victoria. So the idea is to keep checking that information. So we will go around. If the online participants are also able to visualize this, I will put the occupants. It's taking a while. The project is heavy, so it's Canada, so it's challenging. Yes.
Exposure model for a particular area, to request from GEM or anybody website?
Very good question. For the online participants, where can we get models for different parts of the world? Right now, we have some models that are outside, especially in Africa. There are some models out for South America. If you want to get some other models, we are still in the process of documenting and releasing the models. But if you want a model for a specific study, get in contact with us. Through the website, you can say, contact us. You can say, I'm doing my research in Philippines. I would like to get the model for Philippines. And most likely you will get an answer. We will tell you where are the models, how you can look at them. Hazard models are also available. You can check the documentation, the page. In the website that we created for the group, there is a tab for links that you might find interesting. So you can go there and check risk country profiles that we haven't talked much about it. Later, Mari will present another type of view of risk. He's using all these calculated, all these results to come up with the presentation we will see later. Okay, so let's close this and let's go to another output. Let's see the loss exceedance curve. That was the one that we were talking before the break. And we have two outputs, aggregate loss curves and aggregate loss curve statistics. So the idea is we are dividing like the results per realization or the mean and quantiles. So let's first check the mean and quantiles. It's called aggregate loss statistics. You just click on show, and here you have the loss exceedance curve. This is what we were explaining in the presentation, and the meaning is in the x-axis we have the return period. Remember that this return period can be personalized. If I want to investigate the losses for 32 years, let's say, 30 years, you can go and write that in the IPT, in the interface, in the web UI, and you will get the value for that point. So each curve, each color represents the mean, the quantile. You have here the legend, and in the y-axis we have loss. In this case, is people. So how many people are expecting to die? That sounds very crude, but it's what we are modeling for a given return period. If we check the structural, we will see the economic losses. Here we have in the exposure file, there is an option to specify the currency. So here we can visualize that they are Canadian dollars. And we are seeing, for example, for the 100 return period, we are expecting Canada to, no, this is not Canada. This is the portfolio in the surrounding areas of the Charlevoix. We are expecting to have an average annual loss of let's say 0.5 billion. No, sorry, it's not annual, it's the 100-year loss, yes. Insurance companies, that people that work in the CAD modeling world, have a very good sense of saying if this is high, this is low, past event might show some results. Some policies can be derived from these curves. If we, in contrast, show the loss curves, aggregate loss curves, not the statistics, then we will see the curves per realization. So here, what we are seeing is the upper, the lower, and the central values of the GMPs we are using. In the other, in the previous plot, we were seeing was median, mean, weighted mean, and quantiles. Here we are seeing results per realization. Any question? Okay. The last output that we are going to visualize will be the distribution of losses in a map. And it works exactly the same as we plot the scenario collapse buildings, the complete damage buildings. So we come to the average asset loss statistics, and we click in load layer. I think my computer opened it. Yeah. Okay. So we can plot the mean or any quantile, and we plot the mean. We can select if we want a given taxonomy or building class. And we can select between a structural or occupants. If we want to see the economic loss, we select the structural. The number of fatalities, we select occupants. And then I guess for you, you will be very fast because it's the same what we did yesterday. We have to select from the drop-down list at which level we want to see the loss map. We can use the census subdivisions, or if you want to use the other, which one? So I will use divisions. We click OK. And let me close this panel. And now we can see the average annual loss coming from all the building classes in the area related to the Charlevoix scenario exposure.
From all of these ruptures that you see.
Yes, from all of the ruptures that we are seeing here. So if we are summing everything, averaging by the investigation time we are using, and this is the result. So we can do again at the smaller administrative division if we want to start digging into the data. And again, you just download this in CSV file or in a text file and start exploring, filtering, using the software that you prefer, exporting this in GeoPackage, in shapefile if you want them to move to the GIS software that you feel more comfortable with, and start exploring the outputs, giving feedback to the Natural Resources Canada, and also maybe to us if you are using any other region in the world. So this is the hands-on that we wanted to work for today. The examples are there for you to keep exploring different type of calculators. Sometimes will be harder. We will find a lot of error messages, but that's the way modeling works. So let me move to the agenda. Let me see how. I think in the agenda I don't remember what is next. Is
We just want to change the names.
yes, I want to go to there. I think I have it here. We are also working in this at the end, before the end of the afternoon, you will have another tab with the presentations. So we will upload them all there. And the agenda here, after the lunch break, we want to present. We are a bit delayed, but I think at least we managed to present that. So we will continue. We will skip the advanced risk analysis with OpenQuake. Basically, in this presentation, we wanted to show, but we might need, Anirudh has to leave soon. He's flying today in the afternoon. But in short, we wanted to have to let you know that OpenQuake is also used a lot in academia. So there are, and also in practice, there are projects in the nuclear power plants, for induced seismicity. There are like some PhD students also work with us implementing, let's say, directivity effects into PSHA, or then we can export to risk. You can implement ground motion prediction equations. There are a full manual on how to implement it. Before it goes open to everyone, it has to be reviewed and accepted by the developers and the hazard team at GEM. But you can upload and share your GMP. Of course, it has to be peer reviewed before. Also, your models can be shared. We are also working right now on future risk. So it means we have a recent study that has been developed for Costa Rica and some of the Central American region, in which the changes in population, how it's developing on time, is used to predict how the risk landscape will change based on different paths that might take, for example, population growth, urbanization, different settlements. I don't know if you would like to mention some other. Okay. Then also here in the website, we have the links. So if you want to go back, check some more detailed information about GEM, it's here available. I don't know, Mary, if you have some. Otherwise, we will continue with with Mary that will present.
No, I was before we lose Anirudh, I wondered if he would come around here, so those of you online can join me in thanking both Anirudh and Kanta for an exceptionally engaging 2 days of OpenQuake training. They've come all the way from Italy. Anirudh's on his way to India and then to Nepal. Catalina's on her way to South America and points beyond. So we're very lucky to have had them here for 2 days. And I think you will agree that we did a lot in 2 days, thanks to their expert instruction. So on behalf of Natural Resources Canada and Western University, I'd like to extend a warm thank you and on behalf of all the participants here, thank you so much for sharing all your expertise with us.
Thank you.
You will fly this afternoon? Okay. We can't let you escape without some presents. This is Canadian hospitality. So, thank you so much.
Thank you
These
very
are
much.
beautiful purple colors of our university.
Nice. Thank you.
Thank you.
Wait, yeah. By Mary. Good. Thank you very much.
Yeah, I appreciate it.